cations and anions are involved, draw a picture of it, and then look at how many atoms are in there and how many ions are possibly in there. So let's take a look at FeSO4. We have to be able to break that into its cation and its anion, its positive ion and its negative ion. So if I split it, I'm going to get my positive ion and my negative ion. And the positive ion that you see is an iron atom, or an iron ion. And the anion is an SO4. Now, the first thing we have to do is figure out what are the charges. So the charges involved here are going to be easy if we start with the negative side first. If you look up on your sheet, we can actually see that there is a sulfate ion, which is an SO4, and it takes a -2 charge. So if it takes a -2 charge, and we know that all compounds have a total charge of 0, then the iron is going to have to take a +2 charge. So it's going to be an Fe +2 charge, and the name of this compound is going to have to be iron 2 sulfate. So just reading right off the sheet. So we've got iron 2 and sulfate, and we easily get the name. Now, we need to kind of draw a particle diagram of what's going on. So first off, let's draw an iron, so an Fe, and then we'll switch colors, and we need an SO4. So what that really is we've got an S and with 4 O's attached to it. Okay, so there's my FeSO4. Now if I count up the number of atoms in here, I'm going to have 1, 2, 3, 4, 5, and 6 atoms in my compound. So we'll say that there are 6 atoms in there, 1 Fe, 1 S, 4 O's for a total of 6. Now when you drop FeSO4 into water, it's going to break back into its original ions. But there are really only 2 ions in this case. There's an iron ion, an iron 2 ion, and there's an SO4 or a sulfate ion. So where it's going to break will be right here, and it's going to form 2 ions. Okay, now let's take a look at a different way to solve these problems. Say that the question gives you the ions that are involved first of all, and then asks you to turn this thing around and find a name of a compound that would be formed and the formula that would come out of that. So the easiest way to do this is start with a name, and Ca plus is going to be a calcium ion, so we can write always beginning with the cation or the metal. We've got calcium, and then we have to look for our C2H3O2 ion, which when we look down here is going to be an acetate ion. So it'll be calcium acetate. Now the formula of this compound. When we look, we can see that we have a +2 charge and we have a -1 charge. That does not equal 0. So in order to get this thing to balance out, I'm going to need 2 of the acetate ions. I'm going to need 2 of my -1 ions to balance out my +2 ion. So the way I'm going to write that is to say calcium, and then I'm going to need parentheses, a C2, an H3, an O2, and I'm going to need 2 of them. Okay, so 2 of the acetates with a -1 charge, balancing out 1 of the calciums with a +2 charge. Now the particle diagram for this is a little more complicated. So we'll have calcium in the middle here, and then I'm going to need 2 C's, 3 H's, and 2 O's. So 2 C's, switch colors, 3 H's, so we'll go 1, 2, 3, and 2 O's over there, and the same deal on the other side. So we'll need 2 C's, 3 H's, 1, 2, 3, and 2 O's over here. So we'll kind of get something like that. Now, does it matter where you draw the circles? No. What I'm mostly concerned with is, do you know which circles belong together in groups and which circles kind of hang out on their own? So in this case, as long as you had 2 of the blue circles, 3 of the green circles, and 2 black ones together as a group, as an acetate ion, then that's really what we're after here. Okay, so I could actually just take and wall off this and call that an acetate. And we could wall off this ion and call that an acetate, and you've got a calcium in the middle. So right away you can see that I actually have 3 ions here in this compound. 2 acetate ions and 1 calcium ion. And the number of atoms in here can be found simply by adding up all of the circles. 15 atoms in the compound. Basically there's 1 calcium, there's going to be 4 carbons, 6 hydrogens, and 4 oxygens. When you total that up, should be 15 atoms total in the compound. We just wrote out a formula for calcium acetate that involved a parentheses. So why do we need them? Before we talk about that, let's back up to math class and look at something that's a little more familiar. So let's say I give you a formula, y times y times y. You are used to shortening that to just be y cubed. So would you ever write y cubed with the parentheses around the y? And the answer is no, it would be a waste of time. You only have one element inside those parentheses, and so why do you need to parentheses them off? Why do you need to group them in because it's only one thing? So now let's look at a different formula. What if I gave you x plus y plus times x plus y times x plus y? And you would say, well, isn't that just x plus y cubed? It's true. Can you write x plus y cubed instead? And the answer is no, that's totally different meaning. If you write x plus y cubed, you're saying all I want to do is cube the y. If you write x plus y, then you're cubing the entire quantity. Now, when we go to chemistry class, before we wrote out calcium acetate as C2H3O2 with parentheses. Okay, can we just leave them off? Well, we can't, because if we did that, we would wind up with CaC2H3O22. But we don't want to tell people that there are 22 oxygen atoms in a calcium acetate. So the next thing students always ask is, well, with this 2 here, can't I just double all my subscripts and come up with CaC4H6O4? And the answer is no there also, because it destroys a structural cue. So imagine 2 people are hiding in a closet and you quick peek in. And you then describe to your mom, you say, Mom, I just looked in my closet and there was this thing with 4 arms and 4 legs and 2 heads. Well, she's going to think you're describing a space alien or a monster. If you instead say, look, Mom, I saw 2 of these things and they each had 2 arms, 2 legs, and 1 head, your mom would say, yeah, your brother and sister are hiding in your closet. So by putting the parentheses around them, you actually say, look, I want these things to be groups. Not so that it's one unmanageable, huge mess, but that it's actually just 2 groups of 2 C's, 3 H's, and 2 O's. So let's sum this up. When do you use parentheses? So the first couple videos, we never used them because the compounds we were talking about contained no polyatomic ions. So here we're going to take a little flow chart. We're going to say, first step, does the compound have any polyatomic ions? If the answer is no, then you do not need any parentheses. If you do have a polyatomic ion involved in your compound, then we need to ask a further question. When you write the compound out, do you need more than 1 polyatomic ion? If you need 2 or 3 polyatomic ions, you might have a need for parentheses. So if you have more than 1 or 2 polyatomic ions, then you have to ask yourself, do I need to double or triple these polyatomic ions? Okay, so if you have a single polyatomic cation or anion, then the answer is no. You do not need any parentheses.
Is it recording right now?
Yes, it is.
Hello? Sturman. Bye.